Within schemas, we have tables, the familiar rows and columns. Each column has a specific data type that dedicates what kind of information it can hold. So at the top we have database. In database we can have multiple schemas according to our requirement, and then we have in schemas we have multiple tables, and in tables we have multiple columns which can have different data types. Okay, the JSON and JSONB types are particularly powerful for semi-structured data, giving you NoSQL like flexibility within a relational database. So you will get NoSQL like flexibility in a relational database. Understanding these type of fundamental to designing efficient databases. Moving ahead, we have covered the four fundamentals. The real power of any database lies in its ability to manipulate data using SQL. So how to manipulate the data? It's using CURD, C-U-R-D. Create, read, update and delete are the four fundamental operations. Notice the serial type in create is auto generates unique integers, perfect for primary keys. The select statement is how you query data. If you want to query data, how to query data using select statement. And you can filter with where, sort with order by, and aggregate with group by. Okay, so you can form your query by using select, where, order by and group by. These building blocks are foundation of every data interaction you'll ever do in a PostgreSQL. Practice these until they become second in nature. So moving on, we have PostgreSQL architecture. So let's understand what it is. Understanding PostgreSQL architecture helps you appreciate why it is so reliable. It operates on a client-server model. Okay, one client and server. Server is the postmaster. So when you connect, you are interacting with the backend process managed by the central postmaster. Postmaster is the center here. This design allows you efficient handling of multiple concurrent connections. Okay, you can have multiple concurrent connection. How? Through postmaster. Postmaster will get the request from client, and it will give a separate backend process for every client. WAL, W-A-L, write ahead logging. It's a crucial. It records changes before they apply to the disk. So whatever changes you made, it will first return to a WAL and then it will go to the disk. So even if the server crashes mid-operation, data can be recovered. You can recover the data from the WAL files. Okay. The buffer cache keeps frequently accessed data in memory, dramatically speeding up queries. Because if the data is stored in a buffer, the server can get the data right away. The server will have no need to go to the disk. Background workers handle maintenance tasks like vacuuming and replications automatically. Moving ahead, beyond the basics. Okay, so beyond the basic, what we have: advanced data types, multiple indexes, and full text lexi. PostgreSQL isn't just about basic tables and SQL. JSONB gives you NoSQL like flexibility with the power of relational indexing. Okay, with JSON you will have very limited indexing, but with JSONB you can have very flexible indexing. Different index types serve different purposes. B tree is the default and works for most cases. But GIN is excellent for JSON and full text search also. While GIST is great geometric data, full text search is built in, no extra tool needed. Replication is essential for building resilient, scalable applications. Okay, and with stored procedures, with stored procedure, you can push complex logic into a database layer so that it will get executed through a procedure, reducing application complexity. And the data is extensively is truly a game changer. So next is the query planner. So when you run a query, PostgreSQL doesn't execute it blindly. Okay, so its sophisticated query planner analyzes your query. It will analyze and plan and figures out the fastest path. It uses cost-based approach, weighing options like using an index versus scanning the whole table. Whichever has the less cost, it will choose that path. Or choosing between different join methods. The explain command is your best friend. Why? It shows you the plan the database intends to use. Add analyze to see actual runtime statistics. So when you run the query and if you selected the analyze, you can see the runtime statistics. If query is slow, explain analyze will show you where the bottleneck is. Okay. This is essential knowledge for tuning the database performance so that you can get where your bottleneck is and how to resolve it. So moving on to next slide, we have monitoring, tuning and optimization. Monitoring, tuning and optimization are ongoing processes, not one-time task. You have to do this on a daily basis. Regularly check key performance indicators, which is called KPIs, like cache hit ratios, transaction rates, and replication lag. Understanding your workload is paramount for effective tuning. You have to understand what type of workload and how much workload you have. For instance, increasing shared buffer can significantly improve performance for reading heavy workloads. Okay. And always test your configuration changes in a staging environment before deploying to the production. It should be obvious that you have to test before staging environment, then go to production. Then explain analyze command is your debugger. Okay, we did learn about explain analyze in previous slide. And here what we'll get, the explain analyze is your debugger for SQL queries, revealing exactly how PostgreSQL executes a query and where time is spent. Finally, don't forget the routine maintenance. PostgreSQL's MVCC architecture benefits greatly from frequent vacuuming to prevent table bloat. What is table bloat? Fragmentation in a table. Okay, and ensure optimal query plans. These practices together ensure your PostgreSQL instance remain fast and responsive. I'm going to the next slide. Replication and high availability. Replication is the cornerstone of high availability because without replication you cannot have high availability. And for disaster recovery also, you should have replication first. PostgreSQL offers two main types. First is streaming replication, which is highly efficient for creating exact copy of your database in real time. So if you want high availability, you will use the streaming replication. And logical replication. What does a logical replication do? Let's see. Which gives you more granular control over the data which is replicated. Okay, these standby servers aren't just backups. They can take over as the primary in a failover scenario, dramatically reducing the downtime. They also serve a dual purpose by allowing you to offload read queries from your primary database, improving performance and scalability. Understanding these concepts is vital for architecting resilient PostgreSQL system. So what we have learned here, streaming replication, types of replication, streaming replication, logical replication, two types. What does streaming do? It will make the exact physical copy. And what does the replicative do? It will it will replicate the selective data. Okay. And then going to the next slide, here we have indexing. So indexes are like the index at the back of a book. You have a book, you will have an index in the book. So what does the index do? Instead of scanning every page or row, you can jump directly to the relevant information. From the index, you can get the relevant information through page number in a book. So PostgreSQL supports various indexes, each designed for specific workloads. B tree is your go-to for most cases, and GI and GIN excels when you querying inside complex JSON documents and performing full text search. For full text search, you will use GIN. GIST is invaluable for geographical data, allowing efficient queries on spatial relationships. While hash indexes are fast for equality, they were historically less robust and are now mainly used when their specific characteristics are explicitly required. Okay. So choosing the right index can transform a slow query into an instant response. If you use right queries, then you will get good response. If you have bad indexes, then your query will be slow. So what type of indexes we have studied? B tree, which is default, then GIN, generalized inverted, then GIST, generalized search tree, and hash equality. Okay, moving to the next slide, we have window function advanced analytics. Okay, window functions are a game changer for analytical queries. Instead of aggregating rows into single result, they allow you to perform calculations across a set of related rows, often defined by an overclose, while still returning individual rows. Think of it like a moving average or a running total, where each row gets a result based on its neighbors. Okay, they are incredibly useful for ranking data. Example, top 5 product by sales. If you'll set top 5 product by sales, you will use this in that. Okay, for calculating cumulative sums, example, total sale month to date, or comparing values, for example, current month sale versus previous month sale. This capability often replaces complex subqueries in self joins, leading to cleaner and more efficient SQL. Okay, so window functions, row level context, key use cases, and simplified queries. On the next slide, we have stored procedures and functions. Stored procedure and function are powerful tools, and database developer use these very frequently. It is very helpful for them. While they both allow you to define and execute reusable code blocks, there is a key distinction. Okay. What is common? You can reuse the code blocks in both of them. But what is the distinction? Let's see. Procedures are designed for performing actions and can manage transactions, meaning they can commit or roll back. Atomicity. Okay. And functions, on other hand, are primarily for returning values and can be seamlessly integrated into your SQL queries, making them great for calculations or data manipulation within a layer statement. Using them helps centralize business logic, reduce network round trips, and improves application performance. They are the cornerstone of building robust and efficient database applications. So stored procedure and functions. Function will return a value, store procedure may or may not return a value. Next, we have JSON and NoSQL feature. This slide highlights one of PostgreSQL's most compelling modern feature. What is it? It's a powerful JSON and NoSQL capabilities. The JSON-B file data type is a game changer. Why? It allows you to store denormalized, flexible documents right within your relational database, complete with indexing for fast query. So it will allow you to store them in a relational database table, and you can make an index on it for faster queries. You will get faster results. This means you can get the schema flexibility often associated with NoSQL databases without sacrificing the transactional integrity and mature features of a relational system. Okay. Developers can build applications that handle complex, evolving data structures with ease using familiar SQL syntax and functions. It effectively positions PostgreSQL as a versatile hybrid database ready for a wide range of use cases. Okay, so let's move to the next slide. It's understanding transactions and isolation level. There are different type of isolation level in PostgreSQL. So here we go. We'll see. Transactions are fundamental to any robust database system. Okay, every database system will have some transactions. Think of them like a financial transfer. If you think the financial transfer, it will get easier. So either the money leaves one account and arrives in another, it is called atomic or non-atomic. So if it provides this functionality, it is atomic in nature. Okay. So or it doesn't move at all. ACID is the bedrock. Within this framework, isolation levels dedicate how much separation there is between concurrent transactions. PostgreSQL default is read committed. So by default, PostgreSQL is read committed, which is usually sufficient for most applications. Repeatable read ensures that if you query multiple times within a transaction, you will see the same result, preventing a non-repeatable read. Okay, you can note that in read committed, you will have non-repeatable reads. But if you don't want non-repeatable reads, you can work in the mode of repeatable reads, which will give you the same result every time. Serializable is the strongest. After that, third is serializable. So as the name goes, offering complete protection from all concurrency anomalies. Why? Because it will execute the data serially. But it comes with a performance cost, because if you set it as serializable, everything will go in serial and it will choke the database. Choosing the right isolation level is critical design decision for application consistency and performance. If you want like multiple concurrency, then you can use read committed, and if you want single user to perform the task, then you can select the serializable. Okay. The next is joins. Joins are where relational database truly shine. They enables you to reconstruct data relationships defined by your schema, pulling together information from separate tables into a single result. If you ever worked on a database, you should have heard of join or worked on join. So this Venn diagram shows visually the most common join types. What are those? An inner join is like finding the common ground between two tables. Okay. Left and right joins prioritize one table, including all its data and matches from the other. The full outer join encompasses everything from both. The full will be A plus B, both. Understanding these distinctions is crucial for accurate data retrieval, especially when dealing with data that might not have a match in every related table. Okay, so that was all. We have covered Postgres basics, joins, indexes, and some common commands, CURT, operation, atomicity, and all. So we have covered a lot of ground today, from PostgreSQL fundamentals to its advanced capabilities and architecture. Remember, it's powerful, flexible, and free RDBMS that can serve a wide range of needs. The journey doesn't end here. I encourage you to dive deeper into the official document of PostgreSQL site, practice with PSQL, and explore advanced topics like backup, replication, and security hardening. If I'll get the next chance, I'll be covering those. Okay. Build your own databases, experiment, and break things. That's how you learn. Thank you for joining me today. I'm Sagar from PFMS, and I hope this webinar has given you a solid foundation for your PostgreSQL journey. Happy querying.